Welcome to Seamanship 6. Our topic, effects of density. Density is the weight per unit volume. An example unit of density is kilograms per cubic meter. The density of seawater is 1025 kilograms per cubic meter or 1.025 tons. So this is metric tons on board per cubic meter also. While the density of fresh water is 1000 kilograms per cubic meter or 1 ton per cubic meter. The density of brackish water is the density of water other than that of seawater and fresh water, but less than 1.025. Bodies with a density lower than that of water will float, whereas others will sink. Okay, so let's assume that the dimension of this cube is 1 meter on its side, on its length, width, and height. And then we measure the amount of water that can be put inside of this cube. The amount of water, if that is fresh water, will be 1 ton, equal to 1 ton. Or if this is seawater, it will be 1.025 tons. So that is how the density is measured. Okay, the mass of a body or a substance is the value that represents the quantity of matter of the body or substance. The mass will not change even if the body is placed on the moon, the top of a mountain, or at sea level. The force exerted by this mass when it is subject to the Earth's gravitational attraction is the weight of the body or substance. Since gravitational attraction is variable, it is lower at high altitudes than at sea level. The moon's gravitational attraction is weaker than the Earth, etc. The weight of a body or a substance will vary according to its location, but its mass will always remain the same. The gravitational acceleration of the Earth is approximately 9.81 meters per square second. So weight on Earth is equal to mass times the gravitational acceleration. The unit for weight is supposed to be newtons, or equivalently kilograms meter per square second. But it is often shortened as kilogram, and gravitational attraction is considered as a unit 1. That's why on Earth, in non-scientific fields, for example maritime, we consider that 1 kilogram of mass is equal to 1 kilogram of weight. But it is supposed to be 1 kilogram of mass is 9.81 newtons because of the acceleration. Okay, the formula density is equal to mass over volume. We will use that even on board, not only here in school. And then you can transpose by cross multiplying it. Then it will be density over 1 is equal mass over volume. Mass is equal, mass times 1 is equal density times volume. Then if we want to find the volume, then we just transpose the formula. Density times volume is equal mass. And then multiply both sides by 1 over density to cancel here. 1 over density. So your volume now is equal to mass over density. So that is how you transpose the formula. Okay, the effect on box-shaped vessels. New mass of water displaced is equal old mass of water displaced. Thus, remember that the mass is equal to volume times density. So the new volume times new density, that is equal to the new mass. Then old volume times old density, that is equal to the old mass. Then we can derive the new volume over old volume equals old density over new density. So just multiply both sides by 1 over new density. One over new density. Then we can cancel. So new volume is equal to old volume times old density over new density. Then multiply both sides again by 1 over old volume. One over old volume. Then we can cancel now the old volume. Then this one will become new volume over old volume. Now this will become new volume over old volume. And this one will become old density over new density. And then remember that volume is equal to length times beam times draft, that is for box-shaped vessel. So for box-shaped vessel, so length times beam times draft. This is the water level. This is your draft. So since volume is equal to length times beam times draft, then your formula will become length times beam times new draft over length times beam times old draft equals old density over new density. And since length times beam can be cancelled, so your formula will become new draft over old draft is equal to old density over new density. Okay, example 1. A box-shaped vessel floats at a mean draft of 2.1 meters in dark water of density 1020 kilograms per cubic meters. Find the mean draft for the same mass displacement in salt water of density 1025 or 1025 kilograms per cubic meter. So solution, we will use the new draft over old draft is equal to old density over new density. So you can also use the mnemonics nun for this. Nun meaning new draft over old draft is equal old density over new density. Then by transposition or cross multiplication to transpose, then new draft times new density is equal to old density times old draft. Then multiply both sides by 1 over new density. One over new density. Then we can cancel now here. So remaining will be new draft is equal to old density over old draft over new density. So this will be your formula. Then just apply the given 1020 kilograms per cubic meter times your old draft, which is 2.1, divided by 1025 kilograms per cubic meter, that is the new draft, because you are going to salt water or seawater. Then the new draft will be 2.09 meters. One zero two zero times 2.1 divided by 1025. Actually 2.0897 rounded off to 2 decimals. Okay, example number 2. A box-shaped vessel floats upright on an even keel as shown in freshwater of density 1000 kilograms per cubic meter, that is freshwater, and the center of buoyancy is 0.5 meters above the keel. Find the height of the center of buoyancy above the keel when the vessel is floating in salt water of density 1025 kilograms per cubic meter. So remember here that if there is no given value for the density but it is stated as fresh water, it is understood that it is 1000 kilograms per cubic meters. And if there is no value for salt water density, but it is stated as salt water, then it means this is 1025 kilograms per cubic meters, because maybe you will encounter a problem without the value of density, only the salt water and fresh water. Okay, note the center of buoyancy is the geometric center of the underwater volume, and for a box-shaped vessel must be at half draft. That is, if this is your vessel, if this is the water level, it means this is your draft. Then if you are going to write a line from corner to corner of the submerged portion, then the middle will be the center of buoyancy. Okay, so remember that the KB, which is the distance from keel to the center of buoyancy, is 1/2 of draft. This is for box shaped vessels only. There. Okay, in freshwater, KB is 0.5 meters. And then since KB is 1/2 draft, then draft is 1 meter. Because if we go back to the figure, if this is 0.5 meters plus another 0.5 meters, that is 1 meter. Okay, then we apply again the formula new draft over old draft is equal to old density over new density. And then by transposition, and then the new draft will become old density times old draft divided by the new density, because we are looking for the new draft. Now, there is also a shorter way to transpose this. You can multiply both sides by old draft over 1 so that we can cancel, and then old draft over 1. 1000 kilograms times 1 divided by 1025 equals 0.976 rounded off. Then since KB is equal to 1/2 new draft, then the new KB will be, just divide this by 2. That is 0.488 or 0.49 meters. Okay, it has already been shown that when the density of the water in which a vessel floats is changed, the draft will change, but the mass of water in kilograms or tons displaced will be unchanged. That is, new displacement equals old displacement, or new volume times new density, because displacement is weight. And remember our formula, that is weight is equal to volume times density. Because we consider that weight is equal to mass. Then the formula will become new volume times new density is equal to old volume times old density. Thus, by transposition, new volume over old volume is equal to old density over new density. So just multiply both sides by 1 over new density, and then 1 over old volume, and then here 1 over old volume, and multiply also by 1 over new density. Then we can cancel now the new density here. Then we can cancel also the old volume here. So remaining will be new volume over old volume, and then old density over new density. So this will be now the transpose formula. Okay, with ship shapes, this formula should not be simplified further as it was in the case of a box shape, because the underwater volume is not rectangular. To find the change in draft of a ship, to find the change in draft of a ship shape due to change of density, a quantity known as the freshwater allowance must be known. The freshwater allowance is the number of millimeters by which the mean draft changes when a ship passes from salt water to freshwater or vice versa, whilst floating at the loaded draft. it is found by the formula fresh water allowance is equal to the displacement or weight of the ship divided by 4 times the tons per centimeter immersion. So remember, TPC here is, if you remember in your seamanship 2, that is tons per 1 centimeter immersion. And that is 4 millimeter. Now for centimeter, that will be freshwater allowance is displacement divided by 40 times the TPC. Okay, so just remember those formulas. Okay, the proof of this formula is as follows. To show that the freshwater allowance in millimeter is equal to displacement in tons divided by 4 times TPC. Okay, so we have a figure here. Consider the ship shown in the figure that I have shown to be floating at the load summer draft in salt water at the water line WL. Let be the volume of salt water displaced at this draft. So if we go back, this will be the volume. Then let W1 to L1 be the water line for the ship when displacing the same mass of fresh water. And then let V the extra volume of water displaced in fresh water. It means in fresh water, the same ship will displace an extra volume, which is here in fresh water. So small v here represents the extra displacement when the ship is placed in fresh water. So the total volume of freshwater displaced is then the volume of the seawater displaced plus the extra volume, which is represented by the small v. Then remember, mass is equal to volume times density. Thus, the mass of seawater displaced is equal to volume times 1025 kilograms per cubic meters. And the mass of freshwater displaced is volume plus extra volume multiplied by 1000 kilograms per cubic meters. But mass of freshwater displaced is equal to mass of seawater displaced. So your formula will become volume plus extra volume multiplied by 1000 kilograms per cubic meters will be equal to volume of the seawater times the density 1025 kilograms per cubic meters. Then by distribution, V times 1000 is 1000 V. Extra volume times 1000 is 1000 extra volume, or plus 1000 extra volume, is equal to 1025 kilograms per cubic meter times the volume. Now we assume that we already canceled the density here, or the units for density. Okay, then 1000 extra volume will be equal to, so it is supposed to be like this, 1000 small b, or the extra volume, is equal to 1025 times volume minus, we transpose the 1000 volume here to here, 1000 times volume, then 1000 extra volume will be 25 times volume. Then we transpose multiply both sides by 1 over 1000. Then cancel. Then volume here will become 25 times volume divided by 1000. Then this will become 25 over 1000 times volume. So 1000 divided by 25, that is 40. So this will become 1 over 40 times volume, or volume over 40. Now let small w represents the mass of water or the mass of salt water in volume V, or the extra volume, in tons, and let the capital W be the mass of water in volume V in tons. So that is the displacement in salt water. But remember that the formula for weight is equal to fresh water times TPC divided by 10. Then fresh water times TPC divided by 10 is equal to, that is remember the volume over 40, that is the extra volume. But we consider it as a mass, so this is the weight or the displacement of the ship divided by 40. Then by transposition, this will become 40 times freshwater allowance times TPC is equal to 10 times the displacement. Then multiply both sides by 1 over 10. 1 over 10. Then this will become 4 times freshwater allowance times TPC. Then cancel, this will become the displacement. Then since we are looking for the freshwater allowance, then multiply both sides again by 1 over 4 times TPC. 1 over 4 times TPC. Then we can cancel 4, we can cancel TPC. Then remaining will be freshwater allowance is equal to the displacement divided by 4 times TPC. So here, W is the loaded saltwater displacement in tons, or that is the displacement. That is the displacement of the vessel in salt water. Okay, so this is the load line marks. So those are the measurement you have learned already in other seamanship. But what we need to learn here is how to measure the freshwater allowance. So the freshwater allowance is measured from the summer load line, or the upper edge of the summer load line, up to the upper edge of the freshwater load line, as shown here. This is your summer load line, and this is your freshwater load line. So if you do not know how to calculate the freshwater allowance, then just take a measuring equipment and then measure the distance here on the side of the ship. And that will be your freshwater allowance. Then remember that the freshwater allowance in millimeters is written in our certificates or load line certificate. Okay, when the ship is loading in dock water, which is a density between these two limits, summer load line will maybe submerge at the distance that she will automatically rise to the summer load line when floating in open sea and salt water is reached. Okay, the distance by which the summer load line can be submerged, called dock water allowance, found in practice by simple proportion as follows. Let X the dock water allowance, then let PDW the density of the dock water. But remember that the PDW in some books, it is only the DW. No? Then your formula, dock water allowance, we can also use the X here as the dock water allowance. So we can assume that this is your dock water allowance in millimeters. Dock water allowance divided by freshwater allowance is equal to 1025 kilograms minus the dock water density. So this is your dock water density. We can use dW only. Divided by the difference between the seawater density and freshwater density, that is 1025 minus 1000, and that will be your constant 25. So yeah, this is now your formula. Dock water allowance is equal to freshwater allowance times seawater density minus dock water density, or freshwater allowance times the difference between the seawater density and the dock water density divided by 25. Okay, example number 3. A ship is loading in dock water of density 1010 kilograms per cubic meter. Freshwater allowance is 150 millimeter. Find the change in draft on entering salt water. Okay, then let X the change in draft in millimeters. Then X divided by freshwater allowance, or it is better to write it like this. Dock water allowance over freshwater allowance is equal seawater density minus dock water density divided by 25. Then multiply both sides by freshwater allowance over 1, freshwater allowance over 1, so that we can cancel here. Then your formula will become dock water allowance is equal to seawater density minus dock water density times freshwater allowance over 25. So just remember this formula. If we go back, so the formula here is dock water allowance is equal to freshwater allowance times seawater density minus dock water density, that is the PDW, divided by 25. So using our formula, let's put it here. Dock water allowance is equal to seawater density. So just do it like this. What is your freshwater allowance? That is 50 given 150. 150 times, you can use the parentheses, then 1025 minus given is 1011 rather. 1010, and then parenthesis, then divided by 25, then that is 90 millimeter. Meaning, your draft will decrease by 90 millimeter or 9 centimeters. So how did you obtain the 9 centimeter? That is, divide it by 10. Because 1 centimeter is equal to 10 millimeters. So why would draft decrease by 90 millimeter? Because you are coming from fresh water or duck water. You are coming from duck water going to sea water. And remember that if your density is higher, then your draft will be lower. Okay, example number 4. A ship is loading in summer zone in duck water of density 1005 kilograms per cubic meter. Freshwater allowance 62.5 millimeters. TPC 15 tons. The lower edge of the summer load line is in the water line to port and is 5 centimeters above the water line to starboard. Find how much more cargo may be loaded if the ship is to be at the correct load draft in salt water. Note the ship is obviously listed to port, and if brought upright, the lower edge of the summer load line on each side would be 25 millimeters above the water line. Also, it is the upper edge of the line which indicates the summer load draft, and since the line is 25 millimeter thick, the ship's draft must be increased by 50 millimeters to bring her to the summer load line in duck water. In addition, summer load line may be submerged by the duck water allowance in millimeter or X in millimeter. Okay, let's analyze. So the lower edge of the summer load line on the port side is 5 centimeters above the water line. Okay, it means if this is the water line, the lower edge of the summer load line on the port side is in the water line. So this is your summer load line on the port side. So it means it is 25 millimeter because that is the measurement, or 2.5 centimeters above the water line in the water. Okay, on the starboard side, the lower edge is okay, so this is starboard side. The lower edge is 5 centimeters or 50 millimeters. Plus, remember that there is a 25 millimeter thickness or 2.5 centimeters. So it means on the starboard side, on the port side, that is 25 millimeter above. On the starboard side, that is 75 millimeters. Because your lower edge is 5 centimeters above, plus the thickness, that is 2.5 centimeters, so 7.5 centimeters or 75 millimeters. Then here, only the lower edge is on the water, not in the water, on the water. No? So, then it means that the thickness, since the summer load line is measured on the top of this line, then your thickness will be the difference between the water and the summer load line. So that is 25 millimeter. So 25, take the average, 100 divided by 2, that is 50 millimeter. So just try to analyze the problem. So remember our formula, that is duck water allowance is equal to freshwater allowance times seawater density minus duck water density divided by 25. Then we can go to this formula. This is your duck water allowance actually. So 62.5 millimeters times 1025 kilograms per cubic meter minus 1005 kilograms per cubic meter divided by 25 kilograms per cubic meter. Then you will arrive here, and then we can now cancel this, so that remaining will be millimeter. And then by using the calculator, 62.5 times 20 divided by 25 is equal to 50 millimeter. The total increase in draft required is 100 millimeter or 10 centimeters. So where do we get the 100? Because this is your duck water allowance. Then remember that we have a difference of draft of 50. This is the difference between summer load line and the draft in duck water. So 50 plus 50 is 100 millimeter or 10 centimeters. Then cargo to load is increase in draft times TPC. That is 10 centimeters. So remember that we convert the millimeter to centimeter because we are using the TPC, and TPC is ton per centimeter immersion. So 10 centimeters is 15 tons per centimeter. Then we can cancel the centimeters there. Then remaining will be tons. Okay, so cargo to load is 10 times 15 is 150 tons. Okay, example number 5. Your vessel is expecting to load cargo in a port of USA. The water density in that port is 1,000 tons per cubic meters. That is fresh water. Then the ship's displacement is 16,000 tons and the TPC is 45 tons per centimeter. Remember TPC, when you take it from the tables, it will give you only the tons, but it is actually tons per centimeter as the name itself, tons per centimeter. So that is 45 tons per centimeter. What will be the deduction in your vessel's freeboard in that port? Okay, so just apply the formula. Freshwater allowance is displacement divided by 4 times TPC. Then 16,000 tons displacement divided by 4 times 45, which is the TPC, that is 16,000 divided by 180 is 88.89 millimeters. Or you can calculate it also in centimeters. Okay, conclusion. The freshwater allowance is affected by the density in as much as TPC is affected by density. Moreover, sailing from seawater to freshwater will have changes in density of 0.025 tons per cubic meters. 16,000 tons divided by parentheses 4 times 45 equals 88.888. Effects of density on displacement when the draft is constant. Should the density of water in which a ship floats be changed without the ship altering her draft, then the mass of water displaced must have changed. The change in the mass of water displaced may have been brought about by bunkers and stores being loaded or consumed during the sea passage, or by cargo being loaded or discharged. In all cases, new volume of water displaced is equal old volume of water displaced. Okay, so that is our formula. If we go back, new volume of water displaced is equal to old volume of water displaced. Let us derive the formula. New volume of water displaced is equal old volume of water displaced. And since new volume is equal to displacement over density, so we are going to use the new displacement over new density, and then old displacement over old density. And then we can transpose the formula by multiplying both sides by 1 over old displacement and new density over 1, and then both side, on the other side 1 over old displacement, and then new density over 1. So we can cancel the old displacement here, and then we can cancel the new density here. Then we will obtain new displacement over old displacement is equal to new density over old density. Okay, example number 1. A ship displaces 7,000 tons whilst floating in fresh water. Find the displacement of the ship when floating at the same draft in water of density 1,015 kilograms per cubic meters, that is 1.015 tons per cubic meters. By applying the formula new displacement over old displacement is equal to new density over old density, then cross multiply. Okay, that is new displacement times old density is equal to old displacement times new density. Multiply both sides by 1 over old density, 1 over old density. Then we obtain the new displacement, so here it is. New displacement is equal to, because we need to cancel this, then new displacement is equal to all displacement times new density over all density. And then apply the given 7,000 times 1,015 kilograms per cubic meter divided by 1,000. Then the new displacement is 7,105. Okay, if you use the calculator, that is 7,000 times 1015 divided by 1,000 equals 7,000 equals 1,000 equals 7,105 tons. Example number 2, a ship of 6,400 tons displacement is floating in salt water. Salt water meaning 1.025 or 1,025 kilograms per cubic meters. The ship has to proceed to a berth where the density of water is 1,008 kilograms per cubic meters. Find how much cargo must be discharged if she is to remain at the saltwater draft. Then applying the formula, new displacement over all displacement is equal to new density over all density, and then by transposition, we get the new displacement is equal to all displacement times new density over all density. Then 6,400, let's use the calculator. 6,400 times 1,008 divided by 1,025 equals 6,293.85. So rounded off to 9. Then subtract the 6,400, which is the old displacement. Then cargo to discharge is 106.1 tons or metric tons. So as you can see here, this is negative. It means to discharge. Okay, example number 3. A ship of 120 meters by 17 meters by 10 meters has a block coefficient of 0.8 and is floating at a load summer drop of 7.2 meters in fresh water. Find how much cargo can be loaded to remain at the same drop in salt water. Note, this problem should not be attempted as one involving TPC and fresh water. Okay, so the formula for displacement is length times beam times draft times CB times density. Okay, so just apply the formula, then 120 meters times 17 meters times 7.2 meters, that is, okay, let's put it here and use by using the calculator. So 120 times 17 times 7.2, and remember CB has no unit because it is a ratio, times 0.8 equals 11,750.4 will be cubic meters, where we will cancel here. Then times 1 ton, so remaining will be, as your unit will be tons. Okay, so all displacement is equal to 11,750.4 tons. Then, you use again the formula. New displacement is equal to all displacement times new density divided by all density. You need to memorize this for your midterms. So 11,750.4 tons times the new density is the seawater or saltwater density, 1025 kilograms per cubic meters divided by the freshwater or the old density. So the old density here is the density of freshwater, which is 1000 kilograms per cubic meters. Then by using the calculator, multiply this by 1025 and then divide it by 1000 equals 12,044.2 tons. Then subtract the old displacement, which is we calculated earlier as 11,750.4. Then this is positive, so this is cargo to load, 293.76 tons, as you can see. So remember that if negative, that is cargo to discharge. If positive, that is cargo to load. Okay, tons per centimeter. So what is TPC? TPC is tons per centimeter immersion or tons per 1 centimeter immersion. Number of tons necessary to change the mean draft of a vessel by 1 centimeter, and it varies with draft. It is directly proportional to the density and water plane area. In as much as the underwater shape and the draft affect the water plane area, it means that it is also directly proportional to underwater shape and draft. You can also find the TPC in the hydrostatic table on board the ship. Okay, the formula TPC is equal to water plane area times density divided by 100. Is equal to length times beam times CB times density divided by 100. Okay. So what does the formula indicates? It indicates that your water plane area is, if this is your water plane area, we will not calculate this using Simpson's rule, but there is already a block coefficient that we can use. No? So this is your length, this is your beam, and if you remember the block coefficient in your seamanship 2, that is the ratio of the box enclosing the ship shape. That's why we can use the formula water plane area is length times beam times CB. Okay, example 1. The ship is sailing in a brackish water with a density of 1.015 tons per cubic meter. Her length is 180 meters, breadth is 30 meters, and block coefficient of 0.75. What is the TPC of the ship? So by applying the formula, TPC length, your length is 180 meters times 30 meters times CB. Or I mean, length times beam. Yes, length times beam. So, this is square meter. So, when we cancel here and there, 1 meter will remain because this is square meters. So, that is your units will be tons per meter. Okay, use the calculator again. 180 times 30, 5,400 square meters times CB, 4,500 times the displacement times the density, 1.015, then divided by 100 equals 41.1075 tons per centimeter. Why does the unit change from tons meter to tons centimeter? Because the 100 year is actually 100 centimeters per meter, where we can cancel here and cancel there. So that is tons per centimeter. And but just remember that the TPC is tons per centimeter. Okay, from the latter problem, we will calculate the TPC of the ship by using the same ship's particular but with a density of fresh water which is 1,000 or 1.0 tons per cubic meters. Okay, just apply again. This will be square meters. So when we cancel this to there, meter will remain. And this because this is fresh water, so the result will be smaller, 4,050 tons per meter divided by 100 centimeters per meter. So we can cancel here. Then your answer will be 40.50 tons per centimeter. Okay, conclusion, the density of the water where the ship is floating affects the TPC thereof. Thank you for listening and good luck in your exams.